Hello, this is going to be a quick video continuing with the section method. I'm going to be using the same truss as I used in the last videos, but I'm just going to keep going to show you what the section method looks like when you cut through another part of the truss. So this time I'm really interested in solving for F, D, and H, so I'm going to cut through that. So let's draw the cut line. F, G, and H, going right through the middle of them. And now what I'm going to do is redraw that truss. So I'm going to redraw the whole left part of the truss. Two kips coming down, two kips. Got the reaction force RA, A, B, C, D, E, F, G, H. Okay. And now I'm gonna redraw the cut line. And I'm gonna highlight the ones that I'm cutting. Okay, now I can start solving. So when I solve these, I think it's usually easiest to keep the diagonal members for last. So I'm going to go for member F first. Okay, so if I want to get member F, I have to think about, I need to find a point that I can rotate around that F is not touching. So I'm going to say, I forgot to label my points here. 1, 2, 3, 4. I add them on here. 3, 4, 6, 7, 8, 9. Okay. So I'm going to try and rotate around point 4 because F isn't touching it. So let's say sum of the moment around joint 4. I'm going to say that counterclockwise is positive. It's equal to 0. It's equal to. Let's see what there is. So I know there's going to be F. So I'm going to say F. And for now, I'm just going to assume F is positive. I'm going to assume that F is doing a counterclockwise moment around 4, but I don't know yet, just an assumption. So anyway, F, and then you say how far away F is perpendicularly from 4. So that's going to be the same as this distance from 3 to 4. And then the problem it says that that is 5 feet. So F times 5 feet. Plus, what else is there? Well, let's see. Am I going to use member G? No, because it's touching point 4 and it goes right into point 4. Am I going to use member H? No, because it's touching point 4. Am I going to use member E? No, because it's not being cut through. Am I going to use A, B, C, or D? No, because they're not being cut through either. I am going to use, well, am I going to use this 2 kips above point 3? No, because it is pointed right directly at point 4. So there's no perpendicular distance, so there's no moment. Am I going to use this 2 kips? Yes, because it's an external force and it has some distance away from joint 4. So I'm going to say, okay, plus 2 kips. And I can say it's positive 2 kips because if I'm thinking about joint 4 and what rotation this is going to cause, it's going to cause rotation in this direction, which is counterclockwise. So that's a positive moment. And then thinking about the distance that it is away, if I were to extend this 2 kips down, it would show that it's in line with member A. So perpendicularly, it's going to be the same as the distance from 2 to 4, and that's 5 feet. So 2 kips times 5 feet. Okay, now I'm going to use this RA because it's an external force and has some distance away from joint 4. plus RA. And actually, I'm going to say negative RA because the RA, if it rotated around zero point 0.4, it would be creating a clockwise direction rotation. So I'm going to say negative RA times, and then think about the distance. The distance perpendicularly away from 0.4, that is going to be the same as the distance from 2 to 4, and that is 5 feet. So RA times 5 feet. Okay, so I can start solving this. I'd say 0 is equal to F times 5 feet plus 10 feet plus, this is going to be negative. I know RA is 3.33, so I'm going to say negative 3.33 kips 5 feet. 0 is equal to F times 5 feet. And then I'm going to say, well, let's see, 3.33 times 5, 16.65. 10 minus 16.65 is going to be negative 6.65 kip feet. And I can move that over and say 6.65 kip feet is equal to 5 times 5, F times 5 feet. Divide both by 5. 5. F is going to be equal to 6.65 divided by 5, which is equal to 1.33 kips. Okay. And let's think about direction now. Well, I assumed that F was positive, a positive moment, which means it's going in a counterclockwise direction around 0.4. So if I were to draw counterclockwise direction around 0.4, it would look like, that means that this arrow for F must be going this way. If that's the case, well, F is pointed into the point, so that means it's in compression. All right, good. We got F.